Right. So after defining inside structure of the agents, so let's build up the complex models. Okay, beginning of the complex model. So von Neumann self-reproducing automata, we already covered this, right, in the automata week. And this self-reproducing automata could be considered a small agent. Each of these cell will react to the outside stimuli, so it has a perception from outside, and it has transition rule, and it has what? And it has outside output to neighboring cell, right? And suddenly this neighbor cell means what? It means the space of the society. Okay? It could be a geography. This is a grid structured world. However, if we can utilize our imagination, it could be our geography, it could be our social net in many different ways. So this is one way of showing the von Neumann's self-reproducing automata. And self-reproducing, right? The red arrows are growing. Right. So it's not it's not a clear analogy to a human being, social entity. For example, transition time, right? Transition time is not a discrete event, rather this is more like discrete time. And also how to represent individuals. So at that, von Neumann really lived in the early 1940s, 50s, and that was the time, the prime time of the von Neumann. However, sadly at that time, OOP concept was not there, but later in 1960s. So that von Neumann was not able to enjoy the concept of the OOP, so that at the time it was difficult to formally represent such kind of agent concept or cell automata concept. Okay. On top of a cell, this was a mere case of the state. And number of cells and grids are going to be the many agents with interactions. So the interactions and the states, all these together will create individuals. However, such kind of representations and transition times, all those rules were not enough at the time of the von Neumann, and he just introduced cell automata as a self-reproducing machine. Having said that, afterwards, people started to develop the agent-based model, and let's see some example. One example of agent-based model could be an ant-colony optimization. So this is an ant-colony, so many ants, right? Have you ever seen those ants running up and moving something? Their food, right? And ant colony model is a classic example of the agent-based model. And ants have boundaries. And boundaries in recognizing a food source means that this is what? Bounded recognition. Cognition or bounded sensor. And so ants collectively find the food source. So these are collectively means that interactions. However, ants is not a sophisticated animal, so their communication is being limited. We, us, human beings, can communicate with each other through the languages. However, this is a very complex communication method. Rather, ants really should depend upon what? Leaving pheromone behind the trail. Okay? So that ants is leaving trail of pheromone like this, from the foraging area to the nest, going up and down, ants are leaving the porridge, the pheromone. And there is a pheromone trail. And Surprisingly, this trail tends to be the shortest path between the colony to the source. You can check out some simulations developed by the Northwestern people from this link, and it's very nice example, right? And how come this shortest path finding is feasible? That could be an interesting question, right? Why is that? Because going back and forth, shortest path trail will be the shortest route, meaning the more frequency and dense pheromone. And dense pheromone means the more ants, and the deviating path will have less density of the pheromone, so ants will less likely to go there, so that eventually shortest path will be emerged through the interactions of the ant. So let's enumerate some rules of these simple ant agent. So ant behavior is what? Find the food source via anyway, then return to the nest, okay, leaving behind the trail of pheromone, okay, anyway. So meaning that at the initial time, it will just pan out, spread out through this space and try to find the food source. Like this ant looking around like this. There is no food there. However, really fanned out to search the new food source. And then there will be interactions between the ants. However, it's not a direct interaction, but rather the interaction is being done between the ant and the space, leaving the pheromone trail, and ant leaves the pheromone, and then other nearby ants will sense the pheromone through the space. Okay, so here this is bounded recognition, bounded sensory. Then why always the shortest path? We already discussed, right? More ants and less ants, right? And more ants and less pheromone, and more pheromone will make ants to move along the line, and less pheromone will not attract the ants. And this ant colony, this nest, is going to survive through the coordination of the ant. And if ant is not leaving pheromone behind, then each of these ants will not interact with each other through the space, meaning that they are just on their own to find the food source. And that is really make this society keep surviving.